Hey everyone, in this video we're going to talk about DC motors, and this chapter is really going to be all about raising the bar, right? So we're going to deal with more input and output stuff, but instead of working with some of the more basic sensors that we're kind of used to seeing from the previous chapter, we're going to start elevating the complexity a little bit, all right? And so the first stage in which we elevate this complexity, right, is working with these DC motors. So we're going to make things spin, all right? Now, the first thing that I want to do is kind of something similar to what we did with the LEDs, right? In that, well, we first started by plugging it into a battery, then we connected it to an Arduino, then we refined the circuit a little bit with the resistor, right? So we're going to kind of take a similar approach with the DC motor all in this video, all right? So the first thing we're going to do is actually exit this slideshow, and we're going to make a new circuit, and we're going to call it 5.1 circuit. Okay. Now the first thing that we're going to do is just grab a battery and directly connect a motor to the battery. All right. So DC motor. Okay. And then let's just flip the battery because the poles are flipped, or I guess the ends of it are. Let's do red to red. And then black to black. Right? We're kind of used to seeing this from LED. It's the same idea. All right, let's start simulation. And okay, we see it spinning, right? And we can also see its RPM. Now, RPM is just a unit of measure to determine how fast something is spinning. In this case, RPM is very commonly used with motors. Think of it like miles per hour, but for motors, all right? So there we go. We have it spinning pretty fast. 17,568 RPM is very fast. And so you might be like, well, okay, that's DC motors, right? And, well, not quite, right? The whole point of why we're doing this is because we want to control a motor with an Arduino, right? We want to be able to turn it on and off easily. We want to be able to do cool things. Start, maybe turn on for 5 seconds, etc., right? We want to do all those cool things. So we need to get an Arduino involved, all right? So now, right, let's just try directly connecting this to, let's say, an analog pin on the Arduino, okay? So let's grab an Arduino. Okay. Let's get a DC motor. All right, and now it's fairly straightforward, right? And ground, we'll go to ground first. I can make this bigger, yeah, okay. And then let's just connect this to pin 6 because that's nearby. Okay, make this red. Okay, now you're wondering, like, okay, this looks fairly similar to the battery, right? I've got my positive end of the voltage and I got my negative end. And, I should have a complete circuit. So the only thing that's left to do is to write code to turn it on, right? And I mean, we know what that is. It's just analog write, right? So let's just go to text, delete this built-in stuff. Okay. And then all we're going to do, right, is just analog write. If I can write. Analog write 6255, right? Because pin 6, output at the highest possible. We start simulation. And we're like, wait a minute. Why is this only 5555? I mean, if I look at the other one, right, it's like 17,000, right? Why is it spinning so slow, right? So clearly something isn't right, right? Like somehow, like for some reason, and I'll talk about that in a second, but for some reason, this motor is getting less power, right? And well, I don't want that, right? I want to run my motor as fast as possible when connected to the Arduino, right? Because I mean, then what's the point, right? Then the battery will always win, right? Then there's no point, right? So somehow, right, I want this motor to run at max RPM as if it was connected to a battery. So as if is that keyword there, all right? So let's go do some slides and talk about what's going on. Okay, so why can't we use analog write? That's the big question, right? So let's think back to when the motor was connected to the 9 volt, right? It was spinning really fast, and the reason was because of the power source, right? The PWM pins can't output 9 volts, right? These motors can take in a lot more power, as we saw with the battery, right? But here's the issue, right? When you connect that motor in real life, right, to a 9 volt battery, that's basically classified as unregulated power. And what I mean by that is that motors can take in a lot of power if you give it to them. All right, so if I gave it 12 volts, it would have spun at 12 volts. But the issue is that it's unregulated, meaning there's no sort of controller that is regulating that current flow, right? It's just raw power being sent to the motor. And that's a problem because that's when your motors start to wear down really quickly and really badly over time, all right? So we need to do something that can basically sort of do the following three things, all right? First is give 9 volts to a motor that's regulated, all right? Second, we want to be able to change the amount of power that's sent to the motor. So I should be able to be like in code, right? Go at a high RPM and then go at a smaller RPM. All right? And then finally, we also want to be able to change the direction in which the motor is spinning. So remember, analog right only works with positive, right? So like the range is for analog right is 0 to 255. So somehow we need to be able to like change that direction. So instead of spinning clockwise, it'll spin counterclockwise, etc. Somehow we want to change that without needing to physically flip the wiring for the motor to spin the other way. Because, I mean, a solution is, well, you could just flip the wiring, then current will flow the other way, and then the motor will spin the other way, right? That's a solution. But it's not a neat solution, right? Who wants to change the wiring every single time you want to change direction, right? So, in order to do all of this, right, we'll use something called the L293D motor driver. And here's just the gist of the motor driver. Feel free to take this down. But it's basically gives you the ability to regulate the current and voltage flow of your motor. So this means that you can control the direction the motor spins, right? Because you can regulate the current flows. You can control not only the magnitude of the current, but also the direction that it's going in, all right? This also uses an external power source to supply to the motor. So you will end up using a 9-volt battery with this motor driver, all right? And this also uses a PWM pin in order to regulate the voltage being sent to the motor. So this is what allows you to say, all right, I don't want to spin the motor as fast. Let's cut down the number on analog right. All right. Now here's sort of the wiring. So this is motor driver power. So that power is 5 volts from the Arduino. All right. This enable pin is a PWM pin that's used to turn on and change the RPM of the motor. The one in blue over here, these two right here, are input pins. And these are Arduino digital output pins. And in the context of a motor driver, it's an input. But basically, these send high or low signals, and they have to be opposite. And this dictates the direction of current flow. So if I had this pin on high and this pin on low, I might spin counterclockwise. But if I flipped it to have this pin on high and this pin on low, then the motor might flip the other way and spin clockwise instead. All right? So we also have these two output pins. These connect directly to the motor, right? So these are your positive and negative end of the motor. That connects to this part. You got 2 ground wires. And then we have motor power. And that's over here. This comes from your 9-volt battery. That's used to power the motor. All right. And the rest of these pins at the top can be used to wire another motor. All right. So for now, we're only going to focus on the one motor situation. And we're basically just going to get started. So let's go back to Tinkercad here. And okay, so if you didn't know already, you can have multiple Arduinos in Tinkercad. It's just a matter of picking one when you write code for it. So I'll show you what I mean by that when we get to that point. But get an Arduino. And I kind of want to just isolate myself. Yep, there we go. Make maybe a little bigger. Yeah, that's better. Okay, so we have the Arduino, right? And of course, we're going to get a breadboard because it's complicated wiring and well, we don't want to have that bare bones. Okay, make this a little smaller. Let's see. Come on. Okay, that's probably better. All right, so the first thing is, well, we need our motor driver, right? So type in L293D. And there it is. And you're just going to connect it across the breadboard like that. Okay. So the first thing that we're going to want to do, right, is basically extend our breadboard. All right. And by extend, I mean just connect the 5 volts together, just so it's extended on the breadboard rails. Fairly straightforward process. This should feel familiar. Then I'm going to do ground. Okay, cool. So now that we've extended that, the next thing that we're going to do is, oh, I'm sorry. This does not need to go here. I'll show you what goes here in a second. This, let's change to red, is 5 volts. If you remember from my diagram, which I just completely violated, should go here. What's the best way to do this? Let's see. And it's this pin right there. Okay, and you can feel free to use the slide wiring diagram to like, sort of like if you have it open on the side, for example, you know, you can like cross-check what I'm doing here as well. Okay, now the next thing we're going to want to do is let's just go ahead and wrap up these two ground pins. You can see it's labeled nicely here, ground, right? Let's just go ahead and wrap that up. Change this to black real quick. Okay. All right, so now we've got two wires done. Now we need our 9-volt battery, right? So let's go ahead and grab that. Okay. Now for this one, the positive is going to go onto the breadboard, all right? So we're going to extend its positive end on the breadboard. And this is just to make the wiring neat. You don't really need to do this, but I'm just doing it just to make the wiring neat. And if you ever decide to wire multiple motors, wiring it like this will come in handy. Okay, now we know that this is the motor's power, so we can just go ahead and drag that. Again, change the wire colors to match. All right, and now, right, all that's left really is first we have to get the motor in. So, well, actually, let's do the Arduino side first. So this enable pin was the PWM pin, right? And remember, this is responsible for controlling the magnitude of voltage that goes through the motor. So let's connect this to a PWM pin. I'm thinking we use pin 3, since that's the closest one. Okay. Now I'm just going to make this orange just to differentiate it. Feel free to do whatever color you want. Next, we need the 2 digital pins, right? Now let's just use 5 and 6, just because. That's the way I have it set up here. So, okay, pin 5. I'm going to make this like a light blue. Okay, so that's input 1 and then input 2. Go to pin 6. Okay. So do some straightening out. Okay. Well, let's make this like darker blue. Why not? Just to differentiate it. Okay. Now that's done, right? Now you see we have 2 left. We have output 1 and output 2. And those are reserved for the motor. All right. So if I get my DC motor. Okay. Now what I'm going to do is connect the negative end to, let's just do output 2 since it's closer. Okay, make this like black, yeah. And then change the wire color to red before you do this. And then this one will go into IN1. Or by IN1, I mean input 1. We usually call it IN1 and IN2. All right. Now, if you're wondering, well, just remember this one's connected here. All right, don't forget. So even though it looks empty, it's extended. All right, so that should be it for the motor driver. All right, again, feel free to reference the wiring diagram if you are confused. Another thing to keep in mind, and what's really important about this, is that this Arduino and this battery have a common ground signal that's being pumped into this, and that's really important about this circuit, right? That's really the bread and butter of what makes it all work. All right, what makes the motor driver allow to interface with the Arduino and vice versa. All right, so that's just a side note. You don't really need to keep that in mind, but just, you know, if you're wondering, well, hey, I got 2 ground signals coming in together, well, you need that. That's important. Okay, so now that we've done that, let's go ahead and write code for this. Now this is where it gets slightly complicated, but not too bad. We have a library that we're going to be using, so it definitely does make things a little bit easier. Actually, I lied. We're not going to be using a library for this, but you can use a library if you want to in the future. So, one thing to keep in mind, right, is you can switch the Arduino. So this is the first Arduino we had. This is the second Arduino, which is this one. All right. Okay, so let's get rid of this built-in code. All right. Now, the first thing you want to do is go ahead and define your motor connections, right? So, again, we have this enable, and then we have input 1 and input 2. So I'm going to make this code modular enough so that if you wanted to add a second motor, you can. So let's just do, let's say, motor connections. So let's do integer, right? Integer is a whole number, right? Or positive and negative, including 0. E and A, we're going to call it. Enable A meaning the first motor, motor A, is equal to 3 in this case, right? That's this orange pin right here. And then int IN1 is 5, and int in2 is equal to 6. Again, you could use hashtag define to do this. I'm using integers. I'm just doing something different each video so you have an idea that, all right, you know, you can do different things, all right? in1, in2, input 1, input 2, all right? Now, you're going to go ahead and pin mode all of these. Okay, and then the last one. Okay, and then the first thing we're going to want to do is just turn off all the motors, all right? And that's the initial state. We don't want to just immediately send it voltage. All right, no immediate voltage. All right, so that's just going to be, of course, digital, right? And in this case, right, it's going to be in1 and in2 both set to low, right? Okay, so here's the idea, and it's actually really similar to LEDs, and by LEDs I mean the NeoPixel ones. All right, so step 1, specify motor power, and then step 2, turn on motor with the direction you specify. Okay, all right, so let's go through that, right? So let's do step 1. So let's do, or instead of writing out, right, specifying motor power here. So it's going to be analog right, and remember, E and A, or the enable pin, was responsible for that. So it's going to be E and A, and let's do 255, max power. Okay, and then step 2 is turn on the motor. Let's do clockwise. So for clockwise, in this case, it's going to be digital right, in1 low, and then digital right, in2 high. All right, let's go ahead and start simulation. And look at that. We see we have a negative RPM, right? So this is spinning clockwise. All right. Now, if I wanted to do counterclockwise, I just need to flip this. All right. So high, low, start simulation, and notice we go counterclockwise. All right. So let me just write. Let's do counterclockwise. Okay. And something to note is that by motor convention, or rather, I guess just by mathematical convention, I should say, is this is going counterclockwise, all right? So counterclockwise is associated with the positive direction, so that's why this RPM is positive, because it's spinning counterclockwise. Versus if I switched it to low and high, you'll notice that, if you remember, there's a negative RPM. Clockwise is considered in the negative direction. Okay. So that's pretty much it for this. Now, before you guys head out, right, I have 2 additional things. And the first thing is going to be just a quick exercise that I'll show the solution in this video. And the second thing is a bigger exercise that I'm going to have you guys do on your own. All right? So the first thing is, can you create a function that takes in a speed and a direction? All right, so the speed is an integer, direction is also going to be an integer. So if the number passed in is 0, you're going to go counterclockwise. If the number passed in is 1, you're going to go clockwise. So basically what I'm saying is, can you do all of this in one function? All right, so pause the video right now and see if you can do that. Okay, let's do it, all right? So we're not going to return anything because we're directly commanding the motor, right? There's nothing to retrieve from what we're doing, right? So it's going to be void. And again, void just means we're not going to return anything. The function is not going to send anything back to the code, all right? So let's call this spin motor with direction, and then we're going to do int speed and then int direction, all right? Now, if you remember before, we used auto. Auto just means any type of variable, and your code will do the work to figure out what type it is. If you do int, it's the same thing. Now, we could do auto here too, but again, it doesn't matter. Auto is sort of encompasses all types of variables, and it'll, in your code, will figure out what kind of variable you're talking about. Int, you're just specifying that it's an integer. All right, so let's just keep it for auto now, since that's what we're used to doing. All right, so then all you're going to do is analog right, E and A, with the speed that's specified, and then digital right, and then, all right, so this is where, okay, so here's what you're going to do, right? So if direction equals 0, right, what you're going to do is digital right, IN1 high, right? Because we said if 0, then let's do counterclockwise. And then digital right, IN2 low, all right? And then else, if it's not 0, so if it's some other number, right, then digital right, in this case 1, IN1 low, and we're just going to flip it, all right? Okay, so now, right, let's just comment this out real quick. So this part doesn't run, right? And let's just call our own function, all right? Okay, so it's going to be spin motor with direction. And let's do max speed, and let's flip the direction. Let's do clockwise. So if I hit start, look at that. We're spinning clockwise. And then if I change this to a 0 to make it counterclockwise, we're going the other way. All right? And then let's try changing the speed, right? So let's make this like 100, right? Let's see what happens. Notice, it's almost less than half the speed, which makes sense, right? 100 versus 255 makes sense. And then I can flip the direction on that if I wanted to. Maybe let's make this like, I don't know, 50 and make it really slow. Look at that. We're going counterclockwise. Or sorry, clockwise. Okay, so that wraps up everything I wanted to cover in this video. As a last exercise, it's fairly quick. See if you can make the motor stop after 5 seconds. All right, that's your challenge. And something to think about is, well, do you want to do this in loop or do you want to do this in setup? Hint, it's not going to go in loop, all right? So see if you can make the motor stop after 5 seconds, all right? So that about wraps up this video. Something that I would definitely do is keep this wiring diagram from the slides in handy. This is pretty useful, all right? So I would do that if I were you. But yeah, that wraps up DC motors. Thank you so much for watching, and I look forward to seeing you in the next video.